about the Math 1 EOC. I'm going to go through some of these problems with you. It might be more than one video because there's so many, but just that being said, some of this stuff is not as hard as it seems if you know what they're asking for. Okay, so now start with number one. Which choice is the graph of y equals 4 minus x times x plus 2? Okay, notice first, this is calculator inactive, so you can't have a calculator. Now, what these are factors. Okay, they're factors of a quadratic. Now, quadratics make the parabola. Okay, all quadratics make parabolas. And you know it's a quadratic. How you know it's a quadratic is its highest power is x squared, or its highest power is squared. Okay, now when you factor one like this, to get its x-intercepts, what you do, you set the factors equal to 0. Okay, so so this has already been factored for you. It really doesn't matter what the quadratic is, but this has already been factored for you. Okay, now if you set this equal to 0, and then I get my x term by itself, that cancels out. All right, that gives me x equals -2, and that gives me, if I subtract 4 from both sides, that gives me -x equals -4. Well, I can't leave x as a negative like that, so I'm going to divide by -1. Okay, and that gives me x equals +4. Okay, so now let's look at all of our equations and see which one will not work. Okay, now notice that it's the x-intercept has got to be -2 and +4. Now x-axis is here, so where it crosses the x-axis is the x-intercept. All right, now so if +4, so now we've got b, and that's the only one that, and B and A is the only one that crosses at x equals 4. All right, so now let's go ahead. Process of elimination is your best friend here. Let's go ahead and do away with those two right there. Now, if you look, the other x-intercept is -2. Okay, and so your other x-intercept is -2. Well, this is +2. Okay, so since this is negative, since the x-intercept is actually -2, then we know this guy is not correct. So the answer is A. So guys, once again, these are the factors of a, this is the factors of a quadratic. To get your x-intercepts where it crosses the x-axis, you set the factors equal to 0, and I set them equal to 0, got a -2 and a +4. Okay, so that being said, and then I chose between the graphs which one fit just the x-intercepts. All right. Okay, so that was number one. Now number two, we actually have this is still calculator inactive. Okay, now it says, in which graph does the shaded region represent the solution to the solution set for the inequality? Now, guys, knowing that this has a sign like this, that lets me know that that is an inequality. Now, it tells me up here as well, but if you've got a sign that's less than or greater than, that means it's an inequality. When it's an inequality, a shaded region represents all the solutions to that inequality. Okay, so now there's several ways to solve this, but the way I would do it is I would choose. I mean, you could change into y equals mx plus b. You could do that, but that can get kind of that can turn into some more stuff, more difficult stuff. Now, if you guys remember, we did when we did inequalities, when we graphed linear inequalities, we chose a test point to tell us which solutions could possibly be, which side is shaded, and what point made it true. If the test point made it true, you shade the side that the test point is on. If it made it false, you shade the other side. You never shade a false plane. Okay, so we always chose 0, 0. So 0, 0 is the origin, which is represented by the little dots I'm showing right here. Okay, now remember, that point represents the x value of 0 and the y value of 0. Okay, now if you plug that in where x is and y is, that gives you 2 times 0, because guys, we chose a point at x is 0. Well, that y value is also going to be 0. Well, if you think about it, 2 times 0 is 0, minus 0 is just plain old 0. Okay. Now let's think about this. That says, if you read inequality from left to right, that 0 is less than 4. Well, if you think about it, 0 is smaller than 4 or less than 4, so that's true. Now remember, you shade the side the test point is on. Guys, we always use 0, 0. If you can, you shade the side the test point is on. If it is true. Well, it is true because 0 was less than 4. Okay, so now let's see any ones that has the side of the line that's shaded where 0, 0 is. Well, this is shaded. Okay, that's shaded where 0 is. So A could possibly be an answer. This is incorrect because where 0, 0 is, it is not shaded. So that cannot be the correct answer. Okay, looking at C, 0, 0 is not shaded once again. That means that would not be the answer. Now, looking here, 0, 0 is here. It is shaded. That region is shaded. So now we're between A and D. Okay. Now, the best way this is where it depends on what teacher you talk to, how to solve it. Personally, I like doing this. If I leave it in this plain old standard form, that's standard form, by the way, and I change this with an equal sign, okay? I change my inequality with the equal sign because that's what you call your boundary line. That's this guy, right? Whatever. Once we find our boundary line, that's what that is. That's what this equation represents. All right, now, if and guys, I'd use what they call graphing by intercepts. All right, now, to do this, it's very simple. To get your y-intercept, you cover up the x term. All right, well, that's negative y equals 4. So now, I've got to have a positive y. So if I divide by negative 1, that gives me y equals positive 4. Okay, negative 4. Sorry, negative 4. All right, that should be a negative because it's positive divided by a negative. Okay, so now looking at this, my y-intercept is negative 4. Notice it's negative 4, not positive 4. Well, look at this. The y-intercept of this, or when I say intercept, where the line crosses the y-axis, is positive 4. Okay. Well, if I solve it for my y-intercept, the y-intercept is negative 4. Well, I know this can't be right because this is positive 4. So I know A is also not correct. So guys, that being said, D would have to be the answer. Now, keep going a little bit further. Now, I know D's the answer, okay? Just by knowing using my test point, since it was true, it was shaded on that side. And I also did my y-intercept first. It don't matter which one you do first. I just did the y first. Now, also, to get your x-intercept, going back here again, to get your x-intercept, you just cover your y up, okay? So if I cover my y up, that's 2x equals 4. So my y-intercept is x equals 2. Well, if you think about it, guys, this one does have a x-intercept, a positive 2, which all of them had a positive 2x intercept. If you notice, all these had a positive 2x intercept. But now, even though it doesn't show on the graph, knowing that this is a positive 4 y-intercept and that my y-intercept is negative 4, I know this was not the answer. So this one, even though it's not shown on the graph, will have a y-intercept of negative 4. Okay, so D is the answer. All right. Oh, 3. Which expression is equivalent to x plus 2 times 3x minus 3? Okay. Now, with this one, this is a very simple problem. Equivalent means if I multiply this out, because that's being multiplied, 2 parentheses side by side, it means it's being multiplied out. If I multiply this out, which one matches? What if I multiply it out and combine my like terms? Which one matches A, B, C, or D? Okay. So now, guys, once again, if you ask a teacher, one may say this distributive property. One may say use the box method. I like distributive property. Box method is okay too. Some people will say full method, but I don't. Full method only works on binomials, so I don't really call it that. Now, x times 3x. Now, if I'm doing x times 3x, okay. Now, when I multiply like bases, I got an x and an x, and I don't have an exponent. That's 1. Okay. If I multiply like bases, I add the exponents. Well, that's x to the first times 3x to the first. Well, that is 3x 1 plus 1. When you multiply like bases, 2 x's, 2 y's, whatever, you add their exponents. If an exponent is not shown, it is known to be to the first power. All right, so if this is to the first power, that's to the first power. 1 plus 1 is 2. So that's 3x squared. All right, now, looking at my answer choices, all of them's got a 3x squared. So that's really, I mean, I'm doing that, but I mean, it's really not far as a process of elimination. It's probably not helping me a whole lot there. So 3x squared. Now, so I multiply here. Now you multiply this term times this term. All right, now, that's negative 3. X times negative 3 is negative 3x. All right. Now, we've distributed this one to this term and to this term and got 3x squared minus 3x. So now what we're going to do is we're done with this term. We're going to come to this term. Now, all we're going to do here is distribute. I'm going to do it down here because I'm running out of room up there. 2 times 3x, that's 6x. Okay, so 2 times 3x is 6x. Then I'm going to distribute it to this term. 2 times negative 3 is negative 6. Well, just knowing that so far, I know my last term is negative 6. But that's actually not helping me a whole lot either. Now, so in order to answer this problem, if you do it correctly, you will have, if you got 2 binomials, binomials means 2 terms, 2 terms, 2 terms, binomial times a binomial. You will have like terms in the middle like this. Well, if I'm careful with my signs, if I add these two together, that gives me 3x squared, and when I add those together, that gives me negative 3 plus 6 is positive 3x. Okay, so positive 3x. And then minus 6. All right, well now, looking at this, my answer will be B. So just be careful with your signs, class, because that, like I said, that determined that right answer, because all these were really similar. But that was actually the one that was the answer. Okay. It's too bad you can't have a calculator, because you could have plugged that in and matched the graphs and saw that the graphs are completely matched, and then that would tell you this is correct. But this is calculator inactive. Okay, so that was number 3. All right, moving on. All right. A line y equals mx plus b. Now, guys, y equals mx plus b is a linear equation. Okay, passes through the point 1, 6. and is parallel to y equals 4x plus 6. What is the value of b? So now, first of all, here's a key word, parallel. Two parallel lines have the same slope. Well, in y equals mx plus b, the number for m is your slope. M is slope. Okay, so now, so that being said, if I know if they want a parallel line to this line, okay, then I know what I need from this line here is the slope. Well, there's my slope. M represents slope. M is always with your x or your independent variable. Okay, so slope. Now, so I know my slope is 4 because it's parallel. Parallel lines have the same slope. There's my slope. Now, here's my point. Now, guys, what this is an x and a y. That's an x and a y value. Anytime you have a coordinate point, it's an x and y value. Okay. Now, so what I'm going to do, y equals mx plus b, and I'm going to fill in everything that I have. Well, first of all, I have a y value they give me. It says because it passes through the point 1,6. So there's my y value. Now, guys, remember, what is the value of b? That's going to be what I'm solving for. So that needs to, we'll see here in a minute, this is going to get this by itself to solve. All right. M, remember I got this 4 because of parallel slope. That means it's the same slope. Equals 4. Now, the x is going to come from this 1 that they gave you up here. That coordinate 1,6, that's the x value plus b. All right. Now, so if we clean this up, that's 6 equals 4 plus b. Okay. Now, so if and it says, what is the value of b? Well, to solve for b, it has to be by itself. So to get b by itself, I'm going to get rid of this 4 by subtracting it. That becomes 0, cancels out. Okay, and then, but if I do it to one side, I've got to do it to both sides. That's algebra. Now, 6 minus 4 is 2, so b is equal to 2. So what is the value of b? 2. And once again, guys, it'd be great if you had a calculator that you could actually check and make sure it is correct by seeing if it goes to the point. But like I said, I mean, that's not possible here, okay? Because it still is calculated inactive. Now, guys, this is, if you remember, it says 2 functions shown below. Guys, remember, f and g is the name. F is the name of this function. G is the name of this function. It's just a name. It's just, that is the same thing as y. Y equals. But it's just, when you have more than one function, if you put y equals on both functions, when you say, well, which one's which? Well, so they started naming them with letters. There's no work to be done here. That's just a name. X is the variable being used. X is being used as a variable in both of these equations. This is the function g. That's the function f. X is being used as the independent variable. Now, what is the largest integer value of x such that f of x is less than or equal to g of x? First of all, an integer is a whole number. An integer can't be a fraction. A whole number that can be positive or negative. It can be, so an integer, if you classify numbers, an integer is a whole number. It can't be a decimal or a fraction, but it can be positive or negative. Okay? So now, this is what I would do. I would start me a table. This is f of x, and this is g of x. Now, guys, remember, this is this function. That is this function. Okay? So now, I'm going to choose x values to plug in. Guys, I'm going to start with 1 and just work my way up. Okay? I'm going to start with 1. Okay? So if I got an x value of 1, when I plug it in here, that is 1/2 times 2 to the first power. Well, 2 to the first power is 2. Well, 2 times 1/2 is 1. All right. If I plug in 1 here, that's 5 times 1 is 5, plus 2 is 7. Well, now, look at this. F of x let's see. What is the largest integer value such that f of x is less than g of x? Well, right here, we do have f of x is less than g of x, right? So that being said, that even though that's less than, do we know if that is the smallest value? We don't know that. So let's try 0. We need to go less than that, so let's try 0. If I plug in 0 here, that's 1/2 times 2 to the 0 power. Guys, I've talked about this 1,000 times. Any number to the 0 power is 1. That is 1/2 times 1. Well, 1 times 1/2 is just 1/2. If I plug in 0 here, 5 times 0 is 0, plus 2 is 2. So now, f of x is still smaller than g of x. Now guys, to get g of x and f of x, I'm just plugging the number I chose, which is 0, and that's how I'm getting these numbers after I plug in. This is your input, this is your output after you plug it into the function, okay? You got to have 2 columns because you got 2 functions, right? Now, I'm going to erase this for a sec. Hopefully you got that. Let's try -1. Because remember, integer has to be in a whole number, but it can be positive or negative, okay? So let's try -1. All right, now, so if we do -1, that's 1/2 times 2 to the -1 power, okay? All right, now, 2 to the -1 power is 1/2. Now, guys, remember, if you got a negative exponent, we talked about this too, you move it to the bottom to make it positive. So 2 to the -1 power is 1/2. All right, now that's 1/4. All right, if I plug in -1 here, that's negative. If I plug in -1 here, now guys, remember I chose that number. That's 5 times -1 plus 2. Okay, now, what is that? That's -5 plus 2 is -3. So let's see what we got here. Now, for the first time, let's see, 1/2 f of x is less than. Okay, so what is the largest integer value of x such that f of x is less than g of x? Well, looking here, guys, notice that f of x is now positive 1/4 is larger than -3. Okay, so this is actually f of x is now greater than -3. All right, or f of x is greater than. Record. All right, so f of x is greater than g of x. So now, looking at this, if I keep going, what's going to happen is it's just going to keep getting larger and larger, okay, because this is going to be into the negative numbers. So the last integer in which f of x is less than g of x is 0. So the answer is 0. All right, so going back to this, look at the next one, number 6. Guys, it says a company models its net income in thousands of dollars with the function 9x squared minus 54x minus 144, where x is the number of units of its products sold. How many units of its products does the company need to sell in order for the net income to equal 0? Okay. Well, if you think about it, X is the number of units sold. F of X is its net income. Okay. So now, if they want the income, when they want to know when the income's 0, so what we're going to do is take 0 and replace F of X with 0. So let's do that. Now, guys, what I'm going to do here, I'm going to put 0 on the right side, because it don't matter which side you put it on, as long as it's on one side, the equal sign. Now, one thing you want to do here, guys, notice it is still calculator inactive. One thing you want to do here is, if you remember when we factored quadratics, then if this number is greater than 1, it makes it much harder. And plus, you want to always check for a GCF. Well, guys, most of the time, the number up front, the GCF cannot be larger than your smallest number, which 9 is the smallest number. A lot of times, this number here is actually your GCF, the greatest common factor between your 3 numbers. Okay, 9 is actually the GCF. So if I factor out a 9, and divide this by 9, and this by 9, and this by 9, that gives me x squared, because 9's cancel out. Negative 54 divided by 9 is negative 6x. Okay, and if I divide negative 144 by 9, it is negative 16. Now, if I'm factoring this, first of all, I've got a quadratic trinomial, which means tri means 3. 1, 2, 3. It's a polynomial with 3 terms, trinomial. Then here's how I factor it. I'm going to go 2 parentheses. The variable goes up front. Now I notice I've got an x and an x, because x times x is x squared, which would give that back to me, which that's not really a big deal. Now, I need 2 numbers that multiply to give me my c value. That's my c value, because remember, standard form of a quadratic is ax squared plus bx plus c equals 0. That's standard form, okay? I need 2 numbers that multiply to give me my c value. Now let's think about this. That's a negative number. To get a negative number, you got to have, when you multiply, you got to have opposite signs, okay? If you have 2 of the same signs, negative times a negative, that's a positive. And positive times a positive is a positive. So that being said, if I have a negative c value, I've got to have opposite signs. Okay, so that being said, the 2 signs you're going to have in your parentheses is minus plus or plus minus. Okay, now at the same time, I got to have 2 numbers that multiply to give me this. At the same time, add to give me my b value, which is negative 6. Okay, so now coming over here. Now, guys, remember, we took care of our signs when we got these here, okay, when we put our signs in here. How I got this, remember, was I know I've got to multiply to give me that number, so I know my 2 numbers is going to have be one's positive, one's negative. Now, 16. I need 2 numbers that multiply to give me 16. Well, that's pretty simple. 1 times 16, 2 times 8, and 4 times 4. All right, there's the 3 sets of factors that will multiply to give me 16. Now, which one at the same time will add or subtract to give me negative 6? Well, that will be these 2. That will add or subtract to give me my middle number. They will multiply to give me 16, but they have to add or subtract to give me this number. All right, now, so let's think about this just a minute. Which one of these, they have to add or subtract to give me this number. Well, which one needs to be negative and which one needs to be positive? Well, if you look at these 2 numbers, if I do negative 2 plus 8, because I got to add or subtract, let's just add them. Let's say we'll add to get that number. They got to add to give me that number. All right. If I add those 2 together, negative 2 plus 6 is positive 6. Well, that number is negative 6. This is a positive 6. So I know these are the wrong signs. Well, let's switch them up. Let's make 8 negative and 2 positive. All right. Well, negative 8 plus 2 is negative 6. Okay. So now, that being said, the 8 needs to be negative. Going by the signs here, because that gave me my middle number, which is negative 6. There we go. Now, How do I know this is right? Well, I got to multiply to get this number. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. Okay? And if you got a trinomial, it's always 2 parentheses, x up front. Based on this number, if it's negative or positive, tells you what your signs are going to be, and then add or subtract them to get your middle number. Now, so it is equal to 0. Okay, so now to get the number, you going to have to take these factors and set them equal to 0, each one of them. So x minus 8 equals 0, and x plus 2 equals 0. Well, after we do that, if we set them equal to 0, that's x equals 8. You get x by itself, that's x equals negative 2. Now let's think about our two answers real quick. Which one of these answers cannot be a legitimate answer? Well, number one, look at this number right here, negative 2. You can't sell a negative number of units. I mean, you can sell no units, but you can't sell a negative 2 units. However, you can sell 8 units. So there is my answer. That's my answer. So let's recap. Factor the GCF out, got 9. That 9 out here doesn't do anything. It just helps you factor it easier. That gave me this trinomial, okay? Then I factored it. And got x minus 8, x plus 2. All right. Now, so that being said, after I factored it, I set my factors equal to 0, just like we did in problem 1, and got x equals 8 and x equals negative 2. Well, we said we can't have negative 2 units, so that was an extraneous solution, so it was positive 8. All right. All right. Number 7. Okay, Joanna has a total of 50 coins in her purse. The coins are either nickels or quarters. All right, so let's think about this. Nickels are worth 5 cents, right? Quarters, as a decimal, is worth 25 cents, right? All right, so we should know that by just real world things, okay? Nickels are worth 5 cents, quarters are worth 25 cents. Now, it says that she has a total of 50 coins. Well, here's the problem. Which system of equations can be used to determine the number of nickels in and quarters Q that Joanna has in her purse? Well, guys, if you think about it, you're not having to solve anything. They make this really easy. All right, now, let's think about this just a minute. She has a total of 50 coins. Now, it says the coins are either nickels or quarters, so you have no other coins, just nickels and quarters. All right, so now, if nickels is in and quarters is Q, all right, then how do I show she has 50 total coins with all of them being nickels and quarters? Well, if I take nickels, the nickels that she has, plus the quarters she has, I have 50 total coins. Now, I don't know what the value of, how many I have of each one, but I do know that together she has 50 coins. And I know they're both nickels and quarters. They're both either a nickel or a quarter. So nickels plus quarters is equal to 50 coins, and I got that from here. Okay. Now, the total value of the coins is $7.10. Well, let's think about this. I know that nickels are worth 5 cents. So every nickel is worth 5 cents. So if I had 20 nickels, if I plug in 20 here, that 20 times 5 gives me $1, right? That's where I got this. Every nickel is worth 5 cents. Well, every quarter is worth 25 cents. So every quarter I have gives me 25 cents worth of currency. Equals, says she has a total value of $7.10. All right. Now, so let's go back. Nickels plus quarters is 50 coins total. The value of those coins is $7.10. Well, I know every nickel is 5 cents, every quarter is 25 cents, and it gives me a total of $7.10. So this is what you need to look for in your answers. Now, It looks like to me A is going to be your answer. Guys, if you look at the rest of these answers make no sense whatsoever. If you look at them and think about it, they make no sense. All right. So now, that being said, all these are completely bust. A is your answer.